Swayam Prabha. Digital India. Educated India.
Dear students, we are in the last module of the course Fire Safety in Buildings, and I think you have gone through all previous courses. Now, this previous modules, in this particular module, we are trying to bring in the high-rise buildings and their fire regulation, and if necessary the retrofittings for such safety of such buildings. We will also try to include in the discussion the green buildings, the challenges in installing building integrated photovoltaic facades, which are becoming current trends, PV cells at the rooftops, which has been taken as the national mission, battery charging stations, which is again coming in the as an alternative of battery operated cars and vehicles, which needs battery charging stations in replacing CNG or petroleum or diesel. And we also need to look into that whether they are befitting our regular standards, or we really need to have appropriate fire regulations or rectification of the fire regulations in the coming future. So, let us start with the high rise buildings. Now, as you know, the urban scape is getting lot of high rises, rather tall buildings which are beyond 50 meters, and these are housing large number of occupants in a very small area. So, what is the challenge? It is a small site within which a tower is coming up, which is the high rise, and it is housing say around 5,000 people. Now, safety of these people becomes very essential, and this kind of structures being a tower like item, it is very difficult to access. As you have already learnt that our lifts and staircases are the only way to move into these buildings, and lifts under most conditions, that is general conditions, remain non-functional, and the staircase is the only area. We have talked about other additional features with height, what has to be done. We will revisit few of the earlier slides along with the challenges faced by the high rise buildings. So, there can be a chimney effect, that means the fire or the smoke can pass through rapidly because of there may be some shafts, some atriums, some cladding system which covers the building. As I have told in the previous slide, that means in our content, that we will have building integrated facade material, that is photovoltaic material. So, they can also spread fire. It becomes very difficult for firefighters to reach the upper floors, and also the hose which is carrying the water may not have sufficient pressure to sufficient pressure to act upon the fire. So, the problems, if we can list out, it is the spreading of the fire, the violation of fire norms cannot save buildings, because people who will be coming, the firefighters who will be coming will know the building in detail. So, any violation of fire norms will affect the saving conditions or the escape conditions. Limitations of the firefighting equipment, delayed access to the seat of fire. Now, reaching to the particular level is also very important. Further, total evacuation, limitation faced by the firefighters, and also the human behavior. Apart from that, the nature and spread of smoke, we can see the compartmentation, what we have discussed at length in previous modules. So, here strictly the compartment to compartment savior of fire, spread compartment to compartment saving of the fire is required. From within a floor, we have to contain the fire between two compartments. Later, if it spreads floor to floor, failures of doors and windows lead to movement of fire between floor to floor also. Also, we had talked about unsealed service shafts which needs proper sealing with proper fire rated sealing materials. Also, we have talked about sealing voids which goes unnoticed, that is, if there is a false sealing feature in office complexes, it is unnoticed and fire as well as smoke can move through it. AC ducts, as we had talked about earlier, dampers should be appropriately applied. So, controlling spread of smoke is very important. Fire goes behind the smoke, smoke is actually moving faster than that of the fire, and engulfing smoke is actually leading to suffocation and death. So, coming to the norms, yes, NBC provides a lot of guidelines for all these kind of buildings depending on the exterior open spaces and the fire escapes and the external access to the fire escape staircases. Now, you can see here it should be a straight flight built with non-combustible material, free from obstruction, handrail height of 1 meter. In case of mercantile business assembly hotels greater than 24 meters, mandatory fire tower, that is a fire lift, is essential. Now, these are detailed out and in the NBC 4.9.4, and you can get the relevant bylaws for different occupancy load. As I told, the building may be used for office, it may be used for residence, it may be used for commerce. So, based on that, the size and number of requirements of staircases are mandated, because the staircase is the only way to connect from the top to the bottom of a building and help in evacuating the people, other than the fire lift or the fire tower, which is mandated beyond 24 meters. Stair enclosures should be made of fire rated 2-hour materials. So, from material point of view, we have to understand that permanent vent system should be there at the top, which is 5% of the cross sectional area of the enclosure. So, every floor should have vents, and at the top should have vents, every floor should have openable vents, that is louver kind of attachment, and that is also given what is the percentage of the cross section area. There should not be glazing, glass blocks or any internal closing walls. So, within the staircase there should not be any obstruction. If the staircase cannot be ventilated at each landing, a positive pressure of 5 millimeter, as we have already talked about the pressurization mechanism earlier, should be integrated within the staircase enclosures. So, what is important is, because it is the buildings are quite high, that is people have to negotiate the height in case of a fire, the stair enclosure, the fire stair and all other staircases should be proof from smoke infiltration, fire, and safe from its integrity. It should be minimum 2-hour fire rated. Also, it holds good for ramps where various slopes etc. are mentioned. So, it may be because of a hospital or in a basement for cars. So, ramp slopes should be maintained accordingly. Provision of lifts, because as you have understood that we also need a lift in case, because to negotiate height and that much of height beyond say 50 meters, it is very difficult for people to come down, and more people are flowing outside the building, the staircase is becoming more and more crowded. So, provision of lift is mandatory for multi-storied buildings beyond 15 meter height, but beyond 24 meters the fire lift or the fire tower is mandatory, which is, to remember or to reiterate, it is again a staircase, a lift as well as a lobby space, a pressurized lobby space. So, as you understand, lift enclosures should be fireproof, the fire tower should be fireproof with 2 hours of fire rated material, and these should be supported with electricity which is operational under emergency conditions. So, we see here lift shall normally communicate with the should not communicate with the basement. So, we are keeping basement out of reach in case of for any kind of lift. Fire lift will also not enter into it, electric supply should be separate. Also, fire lift should be highlighted with fluorescent paint on lift landing doors and at each floor. So, speed of the fire lift should be such that it should take not more than 1 minute to come from the top floor to the ground floor or from the ground floor to the top floor. Now, coming to the basement, since the lift is not connecting to the basement and basement houses various activities, various services in case of high rise buildings, because the basement is the only place where the AHU can be there, laundry can be there, boiler service can be there, and these are the areas where from fire can also start. So, basement has to be specially treated or separately treated with its own vents, with aggregate cross sectional area, these are all mandated in the NBC. So, you can see vents with aggregated cross sectional area more than 2.5% of the floor area should be there. Smoke outlet and air inlet should be separately there. So, the basement, a lower basement if it is there and a higher basement if it is there, it should be connected with venting to the outside. So, if there are multiple basements and my ground level is somewhere here, so each of these should have connection, each of these floors should throw out the exhaust, that is vent, from the ground level with proper suction systems to the, this is my ground level, this is my basement 0, basement 1, basement 2. So, all these should have venting which should give out the foul air or the smoke outlet which will later become the smoke outlet in case of basements. There can be air throws from inside into these, into each of these levels which is fresh air inlet. Now, these are not habitable spaces. In the upper basement only the activities or the services can be put in, but these two only goes for parking. So, usually no human beings are expected other than the drivers for the in and out are expected in the lower basements. So, it is mandated that all service related requirements should be in the upper basement. Now, these points are narrated here. You see, first basement for services, parking, other permissible services, lower basements are only for providing cars. Also remember, the dead end travel distance is 7.5 meters to any access in case of a basement. So, sufficient number of exits and access ways to be provided within the travel distance of 15 meters. So, that from the dead end and from the dead end it should be 7.5 meters. So, from basement the escape should be very quick. Now, staircase of the basement, as we have already talked about, below the basement the upper staircase is not supposed to come down to the this is the stair block. So, the fire staircase will never come down here. In case of other staircases, it may have a fire check door and then it can travel to the basement. However, fire the fire staircase which is mandated should not come down to the lower to the basement part. Internal mechanical extractors shall have internal locking arrangement to stop supply fans automatically within the basement within the actuation of the fire detectors. These extractors shall be designed as for distress calls. For normal operation it is 30 air changes. Ventilation ducts shall be integrated with the structure made out of brick masonry RCC, that is more than equal to 2-hour fire rating. So, the basement staircase expected to be at the periphery, fire staircase should not go down to the basement. Here you see there should not be any, as I have talked about services, there should not be any kitchen kind of services which works on or runs on gas fuel. So, no kitchen or support service should be provided which runs on gas, fuel or oil. Dewatering pump should be there in all basements, because in case of firefighting water can come into these particular areas and can make the place waterlogged. So, pumps, dewatering pumps from the basement should operate and take out the water which may come in case of fire and which may come and accumulate in case of fire, and it should be easily drained out. Now, you see in case of basements being used only for car parking, the travel distance is 45 meters. Though we had seen in the previous slide that it is mandated that the travel distance should be within 7.5 meters or up from dead end or 15 meters. In case of the lower basements which is only meant for parking, the travel distance can be up to 45 meters. Now, other than staircase and lift, which are the major accesses to into the building for high rise buildings in particular or tall buildings in particular, because those are the only ways you can reach the fire point and for extinguishing purposes. So, other things through which fire can happen are the service ducts, the refuge chutes, electrical services. Now, you see this kind of huge facilities will have a huge, you can see here this is a picture taken by me. So, you can see there is a huge panel room and it is in certain floors or service floors. In case of tall buildings there is a concept called service floor, or it is in the basement or it is in the ground floor. So, you see portable fire extinguishers near electrical panels are supported, and as I told you, electrical fire never works with water, it works with carbon dioxide gas, compressed carbon dioxide gas infilled are over there, so that it replaces the oxygen and puts the fire off. All electrical points should be supported with the MCBs. Safety measures in electrical substations, because various large buildings or tall building or high rise building complexes may also have a substation, and appropriate safety measures are to be kept over there, considering these fires can be electrical fires. Any medium and low voltage wiring should not be neglected, that can pass through false ceilings should be in metal conduits and no wooden items should be used in the entire system. Air conditioning system we have already discussed in previous module, talked about the actuators, the sensors which initiate the smoke damper or the fire damper, which should be automatic in nature and should control or stop the fan in case of fire and stop the smoke movement by damping the by closing the louvers which will be kept between compartment to compartment. Staircases and corridor lights, these should be all connected to emergency lighting. As we have seen in general buildings, it may not be having a support with the electrical connection with the emergency supply, but in this case, because it is a tall building or because it is a high rise building, the staircase and corridor light should be supported with the emergency supply. Now, coming to the last one, which is a helipad. In buildings above 50 meters, some countries even mandate that there should be a helipad, and this is for the rescue operation in case of fire or in case of any medical emergency, where bringing down the patient or the person or the casualty becomes difficult and they can be airlifted. Now, as an architect, you must know that a helipad size is 35 meters cross 35 meters. It can be in the form of a circle, but it is the mandated area is 35 meters cross 35 meters, and there should be a slope from the center to the edge. That is, if this is the center of the helipad, it should have a gradient of 4.6 degree from the center towards the end of it. So, this is where the helicopter can come and rest basically. So, from various high rise buildings have such kind of helipads, and it is becoming mandatory for buildings above 50 meters, but necessary approval from the air authorities are required before providing it. Boiler rooms, hot water supply. If your high rise buildings having water requirement needs, they may be having boiler rooms which should be 2 hour minimum fire rated on all sides. If it is installed in a fire resisting room of 4 hour fire resistance rating, it should be kept within the it should be mandated that it should have 4 hour fire resistant, and there should be fresh air inlet and smoke exhaust separately added to these kind of rooms. Now, here the furnace oil tank is important, and that is why the high fire rating is required. So, doors even should have 2 hour fire rating. Foam inlets should be provided on the external wall of the building near the ground level for fire services. Now, these are very important when there is a boiler room, and this 4 hour resistance, that is very high fire resisting material, usually concrete, it has to be enclosed within a concrete room with a 2 hour fire rated door. Alternate source of electricity, as I have already told, all systems which are essential like the public address system, the fans and blowers, the pressurization system, the exit signs, the smoke extraction system, even the signages, the lift and staircase corridor lighting, all should be supported in case of a high rise building by the emergency electric supply or the alternate source of electric supply. The detection system, all detection systems, because the sprinkler system will not work if it is not supported with fire. So, all automatic systems which are in operation should be supported with the generator or standby electricity, standby power, which will be necessary in case of a evacuation process. So, here you see some more. We are actually in this module, the main objective is to bring the large scale things. Here you see there is a computer server room service where this kind of standpipe based fixed fire suppression system, which is actually carbon dioxide based portable extinguisher, has to be installed in the server room itself, so that any small spark should be immediately addressed to. You can see from this carbon dioxide is again passed through the sprinkler system. Here you can see there is a sprinkler head seen on the ceiling. So, here you can see these are the server trays, which in case of fire, in case of any spark etc., are visible from outside. This is a net door, and the suppression system becomes active in case of any sensing of fire, and it has a fire alarm panel too. So, critical components for modern businesses is computer server room. It is important for offices, businesses means offices too, or even commercial buildings, and these kind of suppression systems are to be placed within the zone. Here are some pictures which can show you that how the tall buildings or the high rise buildings are, the fire is moving between floors from the facades. So, facade fire, here also you can see some fire is here and the smoke is moving and infiltrating into the upper floors, and because of this kind of fire the access to these floors become very difficult. On this wall also you can see the fire is running, and these are live incidences. I have used these photographs from the internet only. You can see the blaze, you can see the fire. Now, these are eye openers. I will come to that slide. So, now let us see the site requirements. So, the fire brigade is so very important to take entry to the site. So, what is the turning radius required? The details are given here. That is for a direct T turn, that is for a U turn. So, the radius of curvature, the outer radius for a fire tender to move is important, though from the very small scale building to the complexes or places where there are multiple buildings, that is building complexes or towers of residential towers are there, all points it should be following these norms. Otherwise, the fire tender cannot reach to the building where they are targeting, and that too it is a high rise building. So, these kind of dimensional requirements, when you are working with the site plan, are to be first chalked out beyond the, and these are to be considered on the road spaces, and no open space, that means mandatory open space, should be encroached by any parking. So, we will see in the following slides, like no high rise building should come below the width of 12 meter road. Road reducing from 12 meter on one side can be acceptable, but road reducing on both sides, you see this one and this picture, it is reducing on both sides is not acceptable. At the dead end of a street, you cannot have a high rise complex. So, a road should be continuous, otherwise it is the end of a road cannot be approved for a high rise building. So, keep these points in mind when you are looking for a site, that how high you can go. Also, as I told, no car parking in the mandatory zones. Usually in of frontage 6 meters are required for such kind of buildings, and with its mandatory side open spaces, which is further written in next slides. Also, coming to the site requirement for the entry of the car, entry of the fire tender, you see minimum 4.5 meters width is required. You can see this dimension, it is 4.5 meters. Also, the height you see for the gate. So, this is maybe the entrance gate, it should be 5 meter high and 4.5 meter clear. Then only a fire tender can move into it, and that has to be maintained for the site. Coming to the other open spaces, that is the side and rear open spaces, you see it is 1/3 of the building height in most of the cases up to 30 meter height. That means 30 meter needs a 10 meter clearance on side and rear. Like similarly 24 meter needs 1/3 of it, that is 8 meter, but after that it varies. Now, this also has a relation with the bulk of the building, that is how big the building is, the building footprint is. If it is 40 meter, it is okay, but if it is greater than 40 meter, then you have to exceed 40, if it exceeds 40 meter, add 10% of the length or depth of the building minus 4 meters to the third column, means that is the right side open space. So, for a 50 meter cross 50 meter block and height 50 meter block, the side space would be 14 meters from here plus 10% of 50 meters, that is 5, minus 4, that means 15 meters. So, if my building block is 50 cross 50, my rear open space and the side open space will be 15 meters, and in all cases my front open space should be 6 meters, because I always have a 12 meter minimum of road frontage for movement and maneuvering of the ladder. Now, coming to the height related restrictions or the mandates, that is 24 meter height, open space at ground level is greater than equal to 6 meters. So, you can see these are the 6 meters. After 24 to 37 meters, these should be 9 meters, and there is one setback. You see here in the second column it is number of setbacks. So, this is also having one setback, but 6 meter, because it is height is within 24 meters. If I have one setback, but beyond 24 to 37.5, it will require 9 meters. Beyond 37 meters to 70 meters, if it has two setbacks, that is this picture, it will be 12 meters, and after that 70 to 120 meters, if it has 3 setbacks, it will be 14 meters, and more than 120 meters and having 4 setbacks, it will be 16 meters at the ground. Why is this? Because the fire tender can push itself and can take the ladder, try to take the ladder to the height to reach the refuge floor immediately below the staircase, where immediately below the floor where there is fire. So, we have discussed that, and we will again try to just revisit that. Now, you can see this is the ladder that can reach, and it can reach up to 104 meters maximum. This ladder, which all the municipal corporations or the municipalities have, which are mostly 25 meters. So, aerial ladder or the sky lift can reach as high as up to 104 meters. Now, for that you need the maneuvering space. So, higher it is, the space beside the building on the site increases. So, these mandatory setbacks and the mandatory open space increase does not match, needs to be followed to allow these ladders to reach to the highest point, which till which they can, the fire people can reach. So, you can see large facades. This is something which happened in India in 2008. You can see fire associated with photovoltaic panels can happen in high rises. Insulation materials is a concern. Exterior cladding material, as you can see, the cladding is burning, that means it may be glass, it may be some composite material. Timber framework with lightweight engineered lumber, which is as I have talked, it works in Australia, Norway, such countries, Canada, they are using some timber framing, though they are fireproof and they are light in weight, but they are also getting affected with fire, they may get affected with fire. Toxicity of the flame is also another component which can lead to human losses. Performance of double skin facade is also sometimes in for insulation purposes. Two skins are used, that means we are not getting into the details. Two skins are used with some infill material or with air. So, sometimes fire can move through such double skin facades and lead to fire movement or smoke movement from one level to another level, as we talked about the stack effect in the very beginning. These are the common slides which we discussed, the dry riser, the wet riser. Above 50 meter it is always the wet riser, below 50 meters it is the dry riser, which are mandated in our codes and standards, are to be inbuilt within the system. Refuge areas, this has also been discussed, they should come first in the 24 meter height, after another 15 meters, another 15 meters you should get. But let us see what is a fire check door or what is a fire drencher. When for, as you see, for this level, this level, this level, and if this continues, it is a common thing. But what happens after 70 meters or 24 floors or taller, alternate floors should be of RCC at the mid landing levels also, and the refuge areas should be refuge areas should be there, but beyond 70 meters what is happening, you must put the fire check floor, which is a 1.8 meter floor and has water pipes around it. So, this 1.8 meter floor is not a habitable space, and you have the entire building is served with a pipeline which actually has nozzles all around it and stops the fire at this 70 meter ring, 70 meter level at the periphery of the building. So, what is it doing? It is a wall wetting sprinkler system. So, what is happening in, if the fire is trying to move up, these things start pouring water on all side of the building facade. So, the building is washed with fire, and that is called a fire drencher. We are washing the building facade with fire, with water. So, it is also called a wall wetting sprinkler system with separate water connection and detection system, also called a water curtain system. So, it is a fire drencher, technically it is also called a wall wetting sprinkler or a water curtain system. We had seen sometimes the glass windows are having a can have a wetting sprinkler system, so that the fire does not damage the glass. We had discussed it in sprinkler systems when we discussed in, I think, in module 4. So, these fire drenchers can be from the roof. If it is 70 meters, it may be at intermediate levels, because tall buildings can go as high as to 828 meters, which is Burj Khalifa. So, it will have so many 70 meters break. So, such kind of systems at 70 meters or lesser than that, such kind of systems are to be inbuilt within the building system to wet the facade, so that the fire cannot move further up. Now, remember, for such drenching systems, you have to have a water source, you have to have a pump unit, you have to have a distribution pipe, which I had drawn here. You have to have a distribution pipe, you have to have a water supply to this, you have to have a control fittings, alarm devices and special nozzles or water heads, because these will force water into the entire facade, and all these should be connected to the generator power, because without that none of the alarms, neither the alarm will actuate, once it is actuated, the pump will also actuate to maintain the water pressure and to flush the entire building facade. Yes, these high rise buildings may have a large floor plate. Again we are revisiting this. We have to remember that a fire hose can serve around 38 meters, and that gives a mandate of 930 meters square per of floor area needs a fire escape staircase or a fire tower if it is a high rise, if it is a high rise building. We had also discussed about the water demands, the static water storage demand. So, for such kind of buildings which is building height of this order, as you can see, has given such mandates as per our NBC guidelines, and you can see this is a site where there is a more than 24 meter building, and you can see the hydrants are, the fire hydrants are there, which can also be accessed, and it can be taken to heights, pulled to heights, so that the yard is, the entire site is also kept safe from fire. Automatic sprinklers, as I had discussed, all such buildings under more than 24 meters, that is coming under the high rise buildings, will have automatic systems, and the basement area should be separated out. They should have their own automatic fire sprinkler systems, which is more than 200 meters square. We had earlier talked that for the upper parts 750 meters square is the mandate for having automatic sprinkler. However, for basement it is only 200 meters square. Automatic heat smoke detection system and multi-level car parking is optional. The number of fire extinguisher required shall be reduced by half if it is having a automatic automatic heat and smoke detection system. Let us see the amount of water requirement. You can see the fire water tank on the overhead. The overhead water tank you see for the D42 building in Kolkata, you can see here the fire tank of 18 cubic meter, whereas the regular tank is actually 22 cubic meter. So, this is the fire tank in the service floor of the 42, in the top floor of the 42, which is a service floor, and you see here the water pressure control. All the red lines you can see, that is the hydrant, dry pump, you can see how much, and you can see the pressure meters here, the valves here. So, these operations are to be done, they are automatically going to start, and these are to be regularly maintained, and this much amount of space has to be provided. So, this is to expose you to the scale of operation and the amount of space requirement which is required. So, the tank itself is 18 cubic meter, and also as architects you must think the structural load that is coming to the system. Yes, I am not getting into the details of the fire alarm system. All such buildings should have fire alarm system, and automatically they should be controlled from the control room. The call is actuated at the particular floor where there is a fire, and if that can be controlled within that zone is the best way how these systems can help and save the building or the dwelling unit in case of a fire. Control room, yes, that is the place from where the entire control happens, and it should be also manned round the clock, because at night times various cases goes neglected. So, the details of all the floor pans should be accessible here, and details of all the firefighting equipment should be here. So, this particular module is to show you, or when a system becomes large in scale and the whole system becomes complex. So, whatever you have learnt in the previous modules, this is actually where the application is to be seen, and it cannot be neglected, as at any point a small fire, if it is not controlled within that compartment, it can lead to a huge loss. One is human loss, next is building loss, and the building loss and bringing back the building to operation becomes a challenge. So, other guidelines which are to be followed are fire drills, fire orders, appointment of fire officer, housekeeping restrictions, fire prevention guidelines, occupancy restriction. Now, as in the very beginning, there was a occupancy load based on which all the guidelines are set. So, this occupancy restriction also has to be maintained in such kind of building. Housekeeping restriction, as we have talked about in hospitals, also it is very important. In high rise buildings, it is also very important. You have to have a proper housekeeping standard. So, consumable items, flammable items, cellulosic items you are keeping in the basement unattended, unaware, cannot be done. So, very well storage management has in the design, in the plan, are to be included, so that storages are appropriately fire rated material are to be maintained. So, we need building rules amendments for fire safety in tall buildings particularly, or in high rise cases, have to have a smoke compartmentation enforced. Experiences can be used to amend the existing fire safety regulations. So, we need trained people or knowledgeable people who can bring in changes. Improved signages, fireproof escape routes and fire rated doors can facilitate evacuation. So, buildings which have or are already made and do not follow such items or such mandates which are currently in place should go for retrofitting, and this retrofitting can actually help the buildings to have a better or a safer life. So, mist sprinklers can be instead of having water sprinklers, they can be having mist sprinklers. Limited ceiling clearances are there in old high rises. So, there can be a newer system of fire detection or smoke detection that can be implemented. So, retrofitting within these buildings can be done, as we have discussed that for heritage structures also it can be retrofitted with appropriate fire safety measures. Now, coming to a short discussion on green buildings, which we are also leading towards sustainability. Green buildings, green building materials. We always try to go for alternative energies. Here is a facade picture taken from Wikimedia. So, you see this is building integrated photovoltaic panels. The facade, when it is a high rise, actually you are getting, your building is getting exposed to the sun. So, you are trying to trap in the building the solar energy from on the building facade by creating such kind of building integrated photovoltaic cells, and these are having high voltage, taking the energy and converting into electrical energy, and these cannot be compartmented. If there is a fire in this kind of facade, it will run through the entire building facade. So, this is how the mitigation measures, this is how it works, and proper codes and standards for making all these are followed, there can be faults within the circuits, and that can lead to fire. So, these photovoltaic cells or systems, they are not one single, but they are continuous whole, and they have some voltages of DC current of 300 to 1000 volts and have the potential risk of spontaneous ignition. So, the hot spots where that such kind of damage can happen, it will lead to large scale facade fire. Roof constructions usually have these. Nowadays, for all institutional buildings, these are becoming mandate. Now, when it is put in such an angle and there is a fire here, the fire, and these are large portions. So, in case of fire, this fire will move through these below these panels, and the firefighters, it is very difficult for the firefighters to access such kind of areas, zones, because these are angular and they are very low in height. The height is also not much. So, to access, and these are all kept on the rooftop. These are heavy, cumbersome to remove and electrically charged. So, safety issues even for the firefighters is becoming a challenge for this. So, these areas are to be addressed properly. Fire risk, fire spread, access for firefighter, electrical safety, heat built up, code compliance, maintenance challenges. These are areas which are to be addressed in the coming codes and standards, and already the codes are in place. So, these are to be considered while design, and they are not just to be implemented on rooftops or on building facades. Here you see the railway station, it is having the photovoltaic cell application. This is just a rooftop where there is a photovoltaic cell, series of photovoltaic cells and cycle stands, etc. Rooftops of institutional buildings where there is no regular people visiting the place can lead to fires. These are the photovoltaic cells or the solar collectors which are converting the solar energy into electrical energy, and these are also having chances of catching fire, because there are connections which can lead to fire hazards, and these are mostly placed at the rooftops, which are not of much concern or not considered under the fire protection. Proper system has to be developed to keep these areas also safe. A spark from this particular point can lead to a fire, and there are cases which have led to fire hazards. We have to be cautious on that. Also, in today's context, the battery charging rooms are coming in practice. If they are within the building or within the building basement, then these areas can become potential areas where from fire can spread. It is water sprinkler might not be beneficial for lithium ion batteries. So, nowadays the battery charging rooms are being planned without much thinking on the fire safety issues, but these can become very dangerous points or places where from fire can happen, and the enclosure within which it is kept, it should be fire rated. These spaces should be well ventilated. There should not be any further cellulosic cellulosic items, and proper planning for these hazards of the battery stations are to be considered. So, this hazard we have considered as a hazardous building, but this is not actually a hazardous building, but it is within a building there can be a charging station. So, the safety issues are to be relooked. In green buildings, as I talked about, these facade designs, cladding systems with BIPV, these are to be looked into, and proper spacing between panels are to be thought about when it is case of a roof. Compartmentation is very difficult, and fire spread and fire breaks are happening in such kind of roofing systems or photovoltaic applications. So, words of cautions are always there, but proper rules and regulations are also getting into the system. So, students, you must be concerned about the safety issues when you are putting these kind of spaces or these kind of cladding materials into design. So, this is one picture where full scale operations or full scale tests are done in the FERL lab of at IIT Gandhinagar. I could visit this place. Here you see all materials, these are thermocouples, they are taking the temperature on one side of the building, other side of the building. Here this building is set with various building materials and how the fire behavior is happening in this unit. So, this is a full scale fire resistance test of cladding materials that was conducted over there, and one or two pictures are taken from there. During this is one picture during the experiment. As you can see, the claddings have come down because of fire, and how the sprinkler system which is inside the building, how it acted. So, this kind of tests are being done to check the applicability of such kind of facade. So, lot of research is also going on in this direction. So, students, take interest, this is as an architect, this is very important that you take it up as a subject and at least integrate the fire safety measures within the building plans which you will be designing for residents or for people, for the occupants, which should be a safe stay. So, these are to be practiced for the coming future, where we are leading to or where we are heading to green design or sustainable design, and we have to keep the major points, we have to keep the fire regulations in mind for such kind of designs. So, with this I would like to thank you all for being with me through the 10 modules, and hope you get enriched or get some knowledge on fire safety, and particularly as architects I tried to bring the key points. Yes, there is another aspect which is the structural design part, structural fire part, which is always there, because if the building collapses, nothing can be done. So, with this I would like to thank you all.